We mentioned in the last lesson that not all fugues have countersubjects. But if they do, the countersubject and the subject will at some point each appear in all the different voices of the fugue. This means that they must each be a good baseline. Combinations of themes that can migrate freely in this way are said to be in invertible counterpoint. Most of the time, invertible counterpoint is done in 2 voices, but it's also possible in 3 and even 4 voices. In 2 voices, it's sometimes called double counterpoint. 3 voices can be referred to as triple counterpoint, and so on. A countersubject normally enhances the subject through contrast. And in fact, invertible counterpoint really only makes sense when the musical ideas are not too similar. Since the whole point is to present the listener with a new musical surface that is nonetheless based on previous material, if the lines are too similar in motives and contour, there's not much reason to exchange them in the first place. Invertible counterpoint in more than 3 or 4 voices is exceedingly rare. The human mind simply can't process large numbers of contrasting ideas at the same time. The result, at a certain level of complexity, turns into a texture rather than a group of themes. In fugue, however, clear melodic lines are a central preoccupation. The positions of the subject and countersubject that make the most difference are those involving outer parts. Exchanging just the middle parts in a rich contrapuntal texture does not affect the overall sound very much. The mechanics of invertible counterpoint are pretty simple. Here's a typical chart for invertible counterpoint at the octave. The upper numbers represent intervals between the voices. The lower ones are their inversions. So an octave becomes a unison, a second becomes a seventh, and so on. In this table, with only one exception, consonances stay consonant and dissonances stay dissonant. This means that if the dissonance treatment is logical with voice A on top and voice B on the bottom, it should also be correct with the voices exchanged. The only interval here that changes categories is the fifth, which becomes a fourth when inverted. So, to write invertible counterpoint like this, we just have to treat the fifth like the fourth it will become when it's inverted, that is to say, as a dissonance, being careful about how it's prepared and left. Here's an example. And here's the inversion. I transposed the upper voice an octave lower so that it's now on the bottom. All the intervals apart from the fifth, fourth stay dissonant or consonant as they were in the original. There are 2 fifths in the original. The C sharp over the F sharp in measure 2, and the F sharp over the B in measure 3. Since they behave as a neighbor note and a passing tone respectively, when inverted they pose no problems. Again, the idea is not to avoid fifths, but to treat them like the fourths they will become. Our example also includes an appoggiatura in measure 1, a suspension in measure 2, an accent in neighbor note measure 3, and a 5-4-2 chord right before the end. This brings up a very important point. The richer the dissonance treatment and the harmony, the more possibilities for successful invertible counterpoint. When the counterpoint is based only on triads, the root and the third of the chord are easy to use. But the fifth of the triad in the upper part, when it moves to the lower part, will create an unresolved 6-4 chord. With seventh chords, all the inversions of a chord can be used, provided the active notes are properly resolved. Accented passing tones also add much more flexibility to invertible counterpoint. Incidentally, we could also transpose the inverted version, for example up a third, to A major. This still counts as an inversion of the original combination. This particular variety of invertible counterpoint is said to be at the octave, since we exchange the voices by moving one of them by an octave. Note that if the original combination had intervals more than an octave apart, for example a ninth or a tenth, the interval would not invert. A tenth would become a third, not a sixth. In other words, the same voice would stay on top. Now an example of triple counterpoint, also at the octave, from Bach's G minor organ fugue, BWV 542. Here the subject is on the bottom, the two counter-subjects are on top. Note how each has its own motives and distinctive rhythmic character, enhancing the subject by contrast. The long note suspensions in the middle voice are particularly rich. Also note the numerous seventh chords. Once again, this kind of counterpoint requires a rich harmonic vocabulary since it will provide more choice for any given moment. Note also that the three themes do not start simultaneously. Their separate entries help make them more independent. The student should go through the score of the whole fugue, noticing the various permutations of the themes as they are presented, and particularly the effect of each theme when it appears in the bass. To write double counterpoint, or eventually triple counterpoint, look for rhythmic motives that contrast with those in the subject. Harmonize the subject in several different ways as richly as possible, looking especially for possible suspensions in seventh chords. And, finally, create a line with the new motives that complements the shape of the subject. In the accompanying PDF, the student will find several subjects for practice. It's also possible to write invertible counterpoint at the 10th or the 12th, where instead of transposing one of the lines by an octave, it's transposed by a 10th or a 12th. The procedure is the same as for invertible counterpoint at the octave. First, make an interval table, noting which intervals change character when inverted. Here are the tables for double counterpoint at the 12th and the 10th, respectively. When inverting at the 12th, the only important change is that the 6th becomes a 7th and vice versa. In inversion at the 10th, perfect consonances become imperfect and vice versa. This means that we can't have parallel thirds or sixths between the two themes, since they will turn into parallel octaves and fifths respectively. This in turn means that the two voices must use only contrary motion and oblique motion. Here's another example, again from Bach, again from the well-tempered clavier, the fugue in G minor from Book 2. This combination is simultaneously invertible at the 15th, that is to say 2 octaves, the 10th, and the 12th. Quite a tour de force. Here's the original combination. The subject is on top. Here's the inversion at the octave, the 15th to be more exact, and transposed to another key. The little change at the start of the subject, the first two notes are a second apart instead of a third, is reflected in the counter subject. We'll discuss this kind of subtle modification, called tonal answer, in the next lesson. Now the inversion at the 12th. I've only quoted the voices with the theme and the counter subject here. Since the 6th turns into a 7th, it now requires resolution. Bach has cleverly arranged the line so that, for example, the 7th A at the start of the second bar resolves onto the G a bit later in the bar, and the same thing happens in the next bar. Here's the inversion at the 10th, transposed to another key. Since, by definition, the inversion at the 10th has no parallel movement anywhere between the voices, it becomes possible to double one or both lines at the 3rd or the 6th with no fear of parallels. Hence the following passage. In both the inversion at the 10th and the 12th, Bach makes changes later on in the line. This reflects an important fact about counterpoint. Entries stand out more than the rest of the phrase. Invertible counterpoint at other intervals is seen even more rarely, but in principle is possible at any interval. Making a little chart of what the intervals become when inverted would tell us how to treat the new intervals. Practically speaking, however, by far the majority of examples of invertible counterpoint are double counterpoint at the octave or the 15th.